Dear friends, welcome back to another session on engineering system design. In the last class we discussed about the graphical modeling techniques and we saw a few techniques for data modeling, basically to identify the relationship between various entities in the system. How do we use the graphical modeling techniques to represent these relationships? We saw a few diagrams like entity relationship diagram or ER diagram. We saw about complex ER diagrams, and then we discussed about another diagram called high graph. So all these were used for basically modeling the data in the system or the relationship between various entities in the system. Today we will discuss about process modeling. As I explained in the previous class, a process model basically defines the functional decomposition of the system function and the flow of inputs and outputs of a system. So here it is more like the functional decomposition. So we use the process modeling to identify the functions in the system. How do we decompose the functions into small functions? So that is the main purpose of process modeling techniques. One of the important diagrams used here is known as the data flow diagram or DFD. In data flow diagram we try to identify so what processing is done, when is it done or how is it done, and where, by whom, and for this what data is needed and by whom, for what and when. So these are the things we need to represent using the data flow diagram, basically looking at what process is done, when is it done, how is it done, or by whom it is done, and what kind of data is needed and who provides the data, from where the data comes or where the data goes out, and how the data processing is carried out. So these are the basic issues we represent using the data flow diagrams. Let us see how actually we can develop the data flow diagrams to represent these processes, and then see what are the different ways of representing the data flow diagrams. As you can see, the basic constructs of DFD are function, data flow, store, and terminator. So these are the four basic constructs for the data flow diagram. First one, the function. As you know, a function is the basic entity of any system. So the function is basically represented using a circle in the data flow diagram. So we use four constructs. So a circle or an oval is used to represent the function or the system. So this is the first construct, and then we use another one called data flow. So data flow is basically represented using arcs. So we use this kind of arcs to represent the data flow. We can actually have different kinds of arcs. We can have a single arc, or you can have a branching arc, or you can have multiple branches also in the data flow diagram. So you can have multiple branches representing that the same data is being flown to different entities. So this is the function, this is the data flow. So this is construct 1, this is construct 2, data flow. The other one is known as store or the storage space. So this is represented in different ways. You can represent the store. So sometimes it is represented like this as a store, basically to store the data or to retrieve data from the store. So we use the term store, or it is represented sometimes like this also. So this is the third construct used in data flow diagram, and the fourth one is known as the terminator. So terminator is nothing but an external system represented using a square. So this is the terminator. The store represents the storage of data, terminator represents the termination of that particular process or the function, where the output from the whole process will go to the terminator and there the flow ends. So these are the four constructs. So we use a function or a system, we represent it using a circle or an oval. We use the data flow, we use arrows to represent the data flow, and then we have a store for database and terminating the function, or it more like an external system which actually provides you, or it actually represents the end of that particular process. So that is the terminator. Let us take a few examples to show how we actually represent or use this kind of data flow diagrams to get the or to represent a particular process. So let us take a very simple example just to see a system taking data from the database and providing to a customer, in the case of an ATM or in case of any other transaction with we do the transaction using a database, we can provide the data from the store and give it to the customer. So here you can see that the system will be represented like this. It is a very simplified representation of a system. So like take an ATM as a system. So this is a system, and then you will be having a database where the account holders will be kept. So this is the store or the database, we call it as a database. And from here the data will be going, and there will be a flow from here, the information flow will be from this direction also, and then this will go to the customer. So here the customer will be the terminator, because the transaction ends with the customer. So the customer will be the terminator here. So this will be there, and there will be an information flow here. So this is a very simple data flow diagram for a transaction. Of course we need to represent all other transaction which is going on inside the ATM using complex DFDs, but this is a very simple way of representing the transaction. You have a database, you have an ATM system, and you have the customer. So the data flows from the store to ATM storage, or the database to ATM, or a request for database is coming from ATM to database. Similarly the customer asks for some transaction and ATM provides the transaction. So it shows the processes or the flow of data within the system and its components. As you can see here, we are using the system representation, the storage representation, as well as the terminator and the data flows. So that was a very simple example. We will take an example of a credit card transaction and then see how to represent the transaction using the data flow diagram. So here we can actually represent the customer as a terminator here, and then you will be having different functions here. So one is basically credit status, that is the function. So this is check credit status. That is one function. Whenever the customer wants to have a transaction, or when he places an order, customer makes an online order through credit cards, there will be a credit checking by the system. So if you call the whole processing system as a, if you represent it is inside a box, and you can see there are multiple functions. One function is to basically check the credit status. Then you will be having a database which is basically the credit rating of the person. So the data from the credit rating, so there will be an enquiry from here to the credit rating, and then there will be another function which actually maintains the credit rating. So maintain, so this is another function, maintain credit rating. So based on this there will be a data flow from here and to here, and based on this information it receives, the order will be validated. So order validation will be another function. This is the order validation, and this will be connected here. So validate the order, order is validated, then this will be providing the service to the customer. So this is again a flow. So here actually I have one, or you can have a reject order based on the validation. So this can be the order, so we are placing an order here, and then this can be the rejection. So based on the credit rating and the checking of the credit status, that will be rejected or accepted. If it is accepted, it will be validated here. So it is validation of order and finally the goods will be delivered to the person. This is the data flow diagram DFD for a credit card transaction. So you can see here all the 4 constructs are here. So this is the terminator which actually the process ends with the customer and as well as it starts with the customer. The customer places an order an online transaction and there is a process or the function which actually check the credit status of the person, and to check that one relies on a database, the credit rating database, and based on that information the credit status will be accepted or rejected, and it is accepted then it will be the order will be validated. That order validation function will do that process, and then once it is validated then the goods will be delivered, and at the same time the credit rating will be updated based on the information provided to the database, and this maintenance of the credit rating will be done this process based on the information it gets from the credit rating database. So this is the way how the data flow diagram is created for a particular transaction. So like this you can actually have various transactions and various processes can be easily modeled using the data flow diagram. Let us take one example for the system engineering design. So as you know that there are different processes in the system engineering. So how do we actually represent the system engineering design process using a data flow diagram? Since you are familiar with most of the processes involved in the system engineering, it will be easy for you to understand how that is represented using a data flow diagram. So here the user, of course it starts with the user, and then there will be a process which actually surveys the users. So this is a process of customer survey or the user survey to find out the requirement, and then this will be analyzed by another process. So there will be an analysis of the survey results, and based on this you will be having a preliminary design. So based on the analysis we will be having a preliminary design process. So this is the preliminary design. So I am just writing all the processes first, then we will look at the database and other transaction of the data. And once you have this preliminary design, then there will be a strategy for the design of the hardware. So there will be a hardware design or hardware study. So study the possible hardware solutions. Then we will be going for the detailed design of the system. So these are the main processes involved in the design. Now we look at the what kind of database is needed for this kind of design process. So one is that there will be a design repository or the design database. So whenever we go for a preliminary design we look at the existing designs. So this is the design repository or where we have different designs already available. This is the design repository. So there will be a interaction, a data flow from here to here. So whenever if you make a new design that will be going into the database. If you want to take some existing design you will be taking it from the database and you will be using it. Similarly, so this flow here is the user requirements from the user, then you have the feasibility document based on the survey and the analysis we will be having a feasibility document which is coming from the user survey, and then again after the analysis we will be taking few more customized requirement from the users. So there will be another input coming from directly to the analysis section. Instead of going through survey, the analysis team will be directly interacting with the users to get more requirement or the specific requirement of particular customers. So that is the data flow from the user to the analysis section. and then there will be another terminator which is known as a program management, which actually decides about the various strategies for the program or the design. So this is the program management. So this is again another entity which actually will be directly interacting with the analysis team, giving the directions on how to proceed with the design, and then we will be having the hardware again based on the analysis we will be having the hardware study, and then there will be other entities like hardware suppliers. So they will be interacting with this, and then we will be having the final developer who actually produces the system. So this is part of the design. So the developer is the one who actually produces the system. So we have a detailed design that will be communicated to the developer, and the developer will design the system, and they will interact and design the system and deliver the system. So this is the design repository, the database, and then so you can see here the interactions are here, design repository and the preliminary design, and this analysis, one of the major functions in the system design process. You can see there are a lot of interaction with the other entities, and you can see the flow of data in this particular process. The survey data will be coming, the user requirements will be coming there. Similarly, the program management, the requirement of the top level management in that particular design will be coming. Similarly, the details of the hardware, existing hardware and the requirement of hardware will be interacting with the analysis team. All this data is completed, then it will be going to the detailed design. Of course, there will be an interaction between the detailed design team and the analysis team also. So here actually the system specification will be given, system specifications or system specs will be delivered to the detailed design team. So this shows the DFT for design process. So you can say this is the data flow diagram for a design process. So by looking at this kind of data flow diagrams, we will be able to identify what kind of interactions are taking place between various processes, or what are the main processes involved in the design, and what kind of interactions are taking place, what kind of database is needed, or what kind of data flow is taking place between different processes can be easily understood using the data flow diagram. That is one type of process modeling, and another one is known as N2 charts. So N2 charts are basically, or N2 charts, or sometimes known as N square diagrams. So the N square diagrams are basically a functional decomposition process. It is giving almost the same kind of information given by the IDEF0 diagrams. We discussed about IDEF0 diagram in one of the lectures earlier. So a similar kind of information is provided by the N2 diagrams. The name N2 comes from the structure or the way it is appearing. Normally if you have n functions or n sub functions in a system, we write all those functions, sub functions, as a diagonal of a rectangular shape. So we will write down all those functions as a diagonal of a rectangle. So these are the n functions. So if you have n functions, so we will make it as an n by n square. We will make it as an n by n array and represent the main functions along the diagonal. So that is how the name comes, the N2 diagram or N square diagram. Now the main functions will be representing along the diagonal, and we give the number 1.0, 2.0, 3.0 and 4.0 and so on. So this is the main function or the divided functions of a system. Now these functions are represented using a rectangle or a square shape, and all the functions are written over here. Then the interaction between these functions are represented using something called a shape like this. So these are the rectangles represent the main functions, or the functions will be represented here. These are the functions, and the interactions are represented using, we call it as the round tangles. Basically a rectangle with the rounded corners. So this actually represents the interaction between different functions. So this is the interaction where we represent it using round tangles, and here the kind of data flow is represented using arrows here. So if there is a data flow from this function to this function, this is represented like this, and this is the forward flow of data. Similarly you can actually have this here also, round tangles, which actually represents the interaction function or interaction between these functions. And whenever there is a feedback from this function to the other function, then it will be given represented like this here also. Again we will use the round tangles to represent the interaction. So finally you will be getting an n by n array, because when you have n functions along the diagonal you will be having an n by n array of functions as well as the interactions, and that is why this is known as an n2 diagram or n square diagram, very convenient for functional decomposition. As I mentioned, it provides you almost the same data as IDOF0 diagram. IDOF0 is more of a standard developed for the Air Force, but this is commonly used diagram employed by many industries. So it is not a standardized one, but it actually provides you almost the same information as the IDOF0 diagram. You can use any one of these diagrams to represent the functional decomposition. So this is the way how the interactions are represented. You can have many kind of interaction over here, and you can have this actually directly interacting to this also. Like that you can have all kinds of interaction can be easily represented using this n2 diagram. You can have the functions along the diagonal and the interactions represented along the side. So you can have on the right side will be more of a data flow to the next function, on the left side will be the data flow back to the functions. We will take a few examples and then see how to use this kind of n2 diagrams for actual functional decomposition. One familiar system which we have discussed a few times is the elevator system. So we will see how to represent the functional decomposition of elevator using the n2 diagram. So here, as I mentioned, we will start with the sub functions. So we can actually identify many sub functions for the elevator. The first one is the, I will write it as accept passenger request. So that is one function. So it will test now one, and then we have other functions. So we have 1, 2, 3, 4 functions here. So we will draw 4 rectangles. So this is 2. So accept passenger request, then control elevator car, then move passengers, basically move passenger between floors, then enable maintenance. So these are the 4 main functions of the elevator. Now we need to find out what kind of interactions are taking place between these functions and what kind of information processing information is passed between the functions. So this can actually be represented using the n2 diagram. So we have 1, 2, 3, 4 sub functions. Now we see what kind of inputs are. So this is the N2 chart, basically this is the N by N array. We can see what kind of inputs are coming to the function. External inputs can be represented at the top for all these sub functions. So any input coming from the outside, and that will here can be represented like this. For example, this will be the request for service. So that can be one input. Similarly, you can have different inputs like emergency support or exit support. So those are the inputs coming to the first function accept passenger request. Similarly, you will be having the input here as the elevator configuration. Like this, there may be many inputs coming to the system like regulations, safety regulations and building regulations. Those things may be an input to the maintenance service. So these are the input coming from the external to the system, so to these functions. Now we have to see what kind of inputs are coming from internally or from these functions. So here this will be represented as using a round triangle. So this is basically a digitized request. So the digitized request will be coming from this function, the first function to the second function. So this is the digitized request coming from here and then flowing to this one. Similarly, there will be a output coming from this function. This will be basically the assignment of cars. So assignment of cars for various floors will be the output from here, which will be going to the move passenger function. Similarly, here sensed malfunction could be a output. So when there is a malfunction in one of the cars, that will be sensed, and so that will be another output from here, sensed malfunction. If any one of the car is not functioning, so that will be given as an input here and output, and this will be given as an input to the enable maintenance. So this way you can identify all the process or the information passing from one function to other function. Similarly, there will be a sensed malfunction coming from all these functions. So here if it is not working properly or there is a malfunction in one of these functions, so this will be a sensed malfunction. Similarly, here also you can have a similar one. So all this will be connected to this one. So if there is any problem with any one of these functions, that will be sensed and that information will be passed to the enable maintenance section. Similarly, there will be some kind of feedback coming here also. From move passengers, the output from here will be the present position of elevator, because we need that information to provide the output to the passenger or the feedback to the passenger. So whenever there is a movement of passengers, the position of the elevator will be given as a feedback. So elevator position and direction of motion will be given as an output. So the complete elevator status will be generated here. So elevator status, and that will be going as a input to the accept passenger request function. This is the output from here which is coming as a feedback to the first function. Similarly, you can actually have this elevator maintenance also will be giving a output here about the position of the status of elevator, and that will be given as here, and then concurrently that output will be going to the accept passenger request function. It should be giving an output to the passenger. So this is again a simplified representation. You can have more complex, or you can represent all other functions also in this one. So this is the N2 diagram for elevator. So this is almost similar to the IDEF0 diagram what you already studied. You can see that these are the functions, and again you can actually go to the next level, you can take this function alone and then identify all the sub functions, and then again create another N2 chart and identify all the sub functions as well as the data flowing from one function to the other function, as well as the feedback coming from the functions back to the sub functions. And here we can represent all the inputs to these functions. So this can actually be extended, we can have many charts like this and to find out all the sub functions as well as to find out the interaction between these sub functions. Let us take one more example. So here I am taking the example what we already discussed while explaining some of the system design examples. So here I will take the example of the auto link system. So we already discussed about the auto link system, which is a system developed for helping the drivers to locate themselves and to get the directions as well as for emergency support. So in this auto link system, if you want to develop a N2 diagram or the functional decomposition, we will identify all the sub functions needed. So we will write down the sub functions here like perform client function, then perform auto link function. So these are the sub functions. Perform emergency response function, then perform GPS function, GPS system function. We can consider these are the four main functions to be performed by the auto link system, and then client info request will be provided by this perform client function, and that will be passed to the auto link function. So this request will be passed here, and then there will be an emergency request function. Basically the auto link function, one of the functions is basically to provide the emergency services. So that emergency request will be passed to the emergency response function, and then perform the emergency response. So here there will be perform emergency response will be another function, and similarly here from the GPS you will be getting the data, GPS signals will be coming here. So the GPS health status as well as the information. So the health status will be provided. The health status and there will be the GPS signals, and this will be, so this will be connected to this one. This, yeah, this is GPS signals. Yeah, here there will be the GPS data will be coming here, and this information will be connected to this one, and this data will be coming over the health status, and then the GPS signals will be coming, and that will be communicated to the auto link function. So this again N2 diagram or the functional decomposition using N2 diagram for an auto link system. So like this you can actually develop the N2 diagrams for many systems, or you can actually take some live examples of the system, and how various organizations work also can be represented using N2 diagram. I will take an example, you can actually see it operational in various situations. So this is basically a system where many of the military or the spy agencies or organizations which work in different situations like underworld operations, or where we need to have a lot of secrecy in operations. So such organizations try to have minimal communication between various entities. So they may be having various organizational entities and various organizational functions, but they will try to ensure that the interaction between these entities are very minimal. So for that they need to ensure that the transaction of data from one entity to other entity is very minimal, and there will not be any direct transaction of data or money or whatever the other information is highly restricted. So how this kind of organization work and how their functions can be represented using N2 diagram, we will see an example and then look at how they are successful in maintaining the secrecy of their operations by limiting the data exchange between various functional entities. So I will take this something like a spy operation, spy or a undercover operations. So though they are not really engineering systems, we can actually analyze these their operations using the N2 diagrams. I am trying to explain the utility of N2 diagram under various situations. So look at how they work. Basically there will be a function to manage their revenues. So whatever may be the operation, there should be a entity which actually manages the revenues of this organization or the process. Then there will be another function as basically they plan their operations. The other one will be distribution of funds. Then recruit and place operatives. So they need to have people who can actually carry out their job. So they need to recruit the people and then place the people are for different operations. Then they need to acquire the necessary hardware. Then place the operatives. So here it is recruit and train operatives basically. Yeah, this is. Then the place the operatives. And carry out task. And there may be another additional function also, separate training function also can be added, but depending on whether they recruit and training as a single function or recruitment is one particular function and the training is another one, then they will be having another function called training also. So I am putting it as TRG training. So these are the main functions which you can identify with any kind of operations where they want to limit the interaction between various entities. So the person who is actually managing the revenue may not be knowing anything about what is happening over here because there may not be any interaction. So that can actually be represented using the N2 diagram and how they actually work. So here you can see that the managed fund, the main operation here is basically to get the funds only. So here actually the job of this entity is basically to get the funds. So that is the interaction here, and then go to the distribution of fund agency and the feedback that will be getting the requirement for the funds from here. So the funding request will be coming, fund request for recruitment as well as for training, that will be from here, it will be going to this as well as to this agency. and here of course there will be a distribution of fund function. So the distribution of funds will be carried out here, distribution of funds and then there will be a feedback about the availability of fund status. So one important thing you can note down here is basically the interaction with whoever is managing the revenue will be interacting only with this distribution of fund agency. They will not be even having any interaction about what kind of operations are being planned. They will not be knowing, because you can see there are no interaction between this entity and these entities and all other entities. So the only interaction which is basically the whoever is distributing the fund. So the revenue management and the distribution of funds are the only things happening here, and all other things are independent of this one. So there will not be any interaction between this function and this function. Similarly, you can see that in all other cases also, here also the here for the recruitment operation. So here the job here, this is to basically provide the funds only. So he will be providing funds for the recruitment operation, and then the resources needed will be intimated, what kind of resources are needed. And that will be informed here, and then the candidate operates will be selected. Okay, so you can see here that the interaction for the plan operator is basically doing this distribution of funds as well as the resource requirements, and that will be given to the funds will be provided to the recruit operation, and they will be doing all the recruitment operation. I can see that there will not be any interaction with the managed revenue and recruitment operation. Similarly, the supply funds here, and then fund for hardware. So for acquiring the hardware, you have to provide funds for hardware will be provided. And then there will be the planning the action. So the plan for the activities for the spy work or whatever may be the undercover operations. So this is the planning. Plan for action will be given to the place operatives, and this is the acquire hardware, and this hardware will be used for the operations. Operatives will be carrying out the operation. So there will be direct interaction with this one, and then the feedback finally may be going back to the managed revenue or the here to the plan operation. So these are the various activities involved in this kind of a spy work or undercover operation. You can see that there will be minimal interaction between various entities. You can see that those who are carrying out the actual task or the plans will not be interacting with any other agency except the operatives only, and finally to the planning operation when it is completed. So none of the people involved in any of these activities will not be knowing what kind of operations or what kind of hardware and what kind of places or training are provided to these agencies. So they always ensure that the interaction between the entities are minimal by providing this kind of a separate loop of managing the resources as well as managing the communication between the functions. So this actually shows the way how N2 diagrams can be used for explaining the interaction between various entities or various functions in a real system, whether it is an engineering system or a social system or a defense system. We can use the N2 diagrams to represent the functional decomposition as well as to show the interaction between these functions. One famous example for this kind of interaction and or lack of interaction in different entities were actually shown in one of the research papers, which actually analyzed the famous or the infamous incident of World Trade Center attack. As you know that the World Trade Center was attacked by using hijacked aircrafts, and they were actually, all those who were part of this hijacking were trained in the US aviation schools. So they were actually undergoing the training and they were preparing for it, but it was not possible for the intelligence agencies to capture them because this kind of lack of interaction between the agencies who were actually planning the attacks and those who are really executing the attack. So if you represent them in a very simple format, you can see that this can be actually represented by three functions. We can actually represent it by three main functions or main entities in this one. So this was the organization which was actually planning those attacks, and this is the cell operations, basically they call it as the sleeping cells, the cell operation, and this was the civil aviation schools or civil aviation training schools or civil aviation operation. I call it a civil aviation operation. From here there was a lot of interaction, and from here also interaction was there. And of course between these two functions there were interactions, and here there were interactions. So here basically the finance and all other help were provided by the organization for the cell operation, and here actually the training requirement and all other requirements were managed by this operation only. So you can see that this particular organization had no direct link with this civil aviation operation, or the interaction between cell and civil aviation operation was totally independent of this organization. And similarly the output was the pilot training. So pilots were trained using the civil aviation operation, and they were actually getting into this loop only. So this loop was completely away from this loop, and that is one of the reasons why nobody could actually trace these cells, or they can identify the people who are actually undergoing cell and what is their intention, because there were no interaction between the main organization as well as the cell operations directly, and all those with the civil aviation operation only the cells were really interacting with that. So this actually shows that by providing this kind of framework where we try to reduce the interaction, it is possible to keep the data safe or to keep the data away from the people who are actually looking for data. So we can actually use this kind of diagrams to analyze this kind of social systems as well as the security concerns. We can analyze the behavior and then try to use this data to understand the type of interactions, the type of data flow, and then where the various entities interact with the system. So this is one of the main methods used for modeling the engineering systems and their interactions. So in this class we discussed about the process modeling. Process modeling is basically to look at what kind of data, what kind of information passing is needed, and what are the different functions involved, and when a particular process is to be done, by whom it is to be done, and what kind of resources are needed for that one, and what kind of data flow is taking place. And we saw two methods. One is the data flow diagram. we represent the various functions using circular or oval shapes, and then the data flow using arcs, and we have another two terms called terminator as well as database to represent the various entities in the system, and then we represent the flow between these functions and entities using the data flow diagram. Another method of process modeling is the N2 diagram, where we have an n by n array of functions and their interactions. The main functions are represented along the diagonal, and all of the interactions are represented using off diagonal elements. This N2 diagrams basically can be used for functional decomposition, and at the same time it can be used to identify all kinds of interaction taking place between the functions and sub functions, and that actually helps us to identify the various requirements of communication as well as data exchange, and gives us a complete picture of what kind of interactions take place, what are the sub functions, and how do we actually develop the functional architecture from the functional decomposition. N2 diagram gives almost the same information as the IDEF0 diagram, but then again it is a more informal way of providing the architecture or providing the functional decomposition in a graphical way. The next modeling technique is behavior modeling, where we try to identify the control and activation of various functions, and then the control structure, and how a particular activity is activated, or how a particular activity can be stopped, or how it can be started under various situations. So all these can be modeled using behavior modeling techniques. We will discuss about the behavior modeling techniques in the next class. Till then, goodbye.